Alright, so today we are going to be building off of what we've been doing in class, and we are going to get more technical with how we simplify algebraic expressions and start to talk about how those are related to the grouping and things that we did yesterday. Here's some vocab words you're going to want to know. Our first one is term. So a term is a number, a variable, or a product of numbers and variables. And remember, variables are just letters. And product, remember, means multiplication. Terms in an expression are separated by addition or subtraction. So here, if you're looking at our first example, 7x is a term because it's separated by a addition sign from everything else. 5 is a term, it's just a number separated. 3y to the second is a term, y is a term, and x over 3 is a term. So in this expression, we have 5 terms. A coefficient is a number that is multiplied by a variable in an algebraic expression. A variable by itself, like y, has a coefficient of 1. So for example, if you see y, it is really 1y. So here in our example, we have 7x. 7 would be our coefficient, and x is our variable. And just as a reminder, the reason why it's 1y is because, for example, like 7x really means x plus x plus x plus x plus x plus x plus x. So when it's 7x, it's really x added to itself 7 times. So the reason that y is really 1y is because it's not being added to anything else. There is just a single y. Now, relating back to what we did with the different writing utensils, we were trying to look for what we would consider like terms in that situation. Now, here we were able to look at things in different ways. Mathematically, that doesn't happen. We can only look at the numbers and the variables and the coefficients and the terms in certain ways dictated by the rules that math has set. So in math class, like terms are terms that have the same variable raised to the same power. And the coefficients do not have to be the same. However, constants like 5 and 3.2 are also like terms. So if you have numbers written without a variable, those are like terms as well. In our first example, we have 3x and 2x. Those will be considered like terms. 5x to the second and 2x are unlike terms because the powers or exponents are different. Since this one has an x to the second, what this one actually means is x to the second plus x to the second 5 times. And the other one that's 2x is really x plus x. Well, x plus x is not the same thing as x times x, so that's why they're unlike terms. Our next one, w and w over 7 would be considered like terms. 6a and 6b would be unlike terms because the variables are different. Because a is not the same as b. Just like for some of you when we separated, the pencils were not the same as the markers. And then lastly, we have 5 and 1.8 are like terms because they're both numbers. 3.2 and n are unlike terms because only one term contains a variable. So since 3.2 or 3 2/10 doesn't have a variable with it, it can't be combined with n. So we want to identify the like terms in the list. A lot of times when I model this, I model it using shapes and or colors to just kind of help differentiate. I always start with the one that's furthest to the left. So in this case, it's 3t. So using our rules of what math-like terms are, so the same variable to the same power, we're going to group using squares or rectangles around any term that has a t. So in this case, it would be 7t. So one of our like terms would be 3t and 7t. Our next set of like terms, I'm just going to move to the one that's to the left, is going to be 5w to the second. So now I'm going to look, what other terms have a w to the second? Well, there's a 4w to the second, so that would be our second set of like terms. And then lastly, I have 9v, which would be a like term to 8v. I wrote these on separate lines, but technically it would be one expression, but since there's no operations in between, I just wanted to show we have 3 sets of like terms in that expression. Why don't you try this one on your own? Go ahead and pause the video and either use shapes or colors or just physically write them out how you would to group these terms with its like terms, and then check when you are done. In this case, we have 2x would be the same as 8x. 4y to the third is going to be the same as 5y to the third. And then lastly, 5z is a like term with 8z. So here we had 3 sets of like terms, all based on their variables. And now this is where we see how it relates to what we did yesterday. So combining like terms is like grouping similar objects. So for example here, there are blocks listed in each part of our expression. In our first one, we have 4 blocks that are each x. So we have the term 4x. In our second one, we have 5 blocks all with x. So we have 5x's. And now in our last one, we put those together. So we have our 4x's on top, our 5x's on the bottom, but now we have a total of 9x's. If we're going to combine like terms that have variables, we just add or subtract the coefficients. The variables themselves are not going to change. So let's look at a couple of examples of simplifying without a model. So if we have 6t and 4t, we have a subtraction sign in between. You could draw out t plus t plus t. So now I have these 6 t's, and I'm taking away 4 of them. So I'm going to group these, and now these are all gone. So what am I left with? I'm left with simply 2t. Now obviously that works when you're using smaller numbers, but on this next problem, you're probably not going to have to draw out 45x's and 37y's. So what we're going to do is we're just going to look for like terms like we did before. So in 47x, since there isn't another x term, that 45x is just going to stay 45x. Now I'm going to go to my next shape, or my next shape. So I did a square, now it's a circle, so I have 37y. You'll notice that there is nothing that's like 37y because there's no other y terms. I'm going to copy that over. Oops. And now lastly, we have plus 87, which would be a constant. Since there aren't any other constants, it's going to stay. If you notice, our simplified one is the same as the beginning, so we could simply just write simplified when we look at it. Now let's try one that's a little bit more challenging. If you're up for the challenge, go ahead and pause the video and try this one out on your own. Once again, I'm going to look and use shapes to kind of like highlight our different shapes that would be like terms. I'm going to start with a to the square. So I have a 3a to the square, and then I have a 2a to the square. I want you to notice I put a box also around the operation, because remember when you're combining like terms, you're going to use the operation that's in front of your second term. So if I have 3a to the seconds and I'm adding 2 more, I now have 5a to the seconds. If it helps, you can cross those off. And now I'm going to move on to b. So now I have 5b to the second. The only thing is you want to be careful here, because notice here I have a b to the second and here I have just b. Since this one is b to the second, remember that's like b times b, where 4b is that b plus b plus b plus b. So in this situation, our only other like term would be 4b. So now as we're looking at this, we have 5 b's, but I'm taking away, because there's that subtraction sign, 4 b's. So now I am left with 1 b. And you wouldn't have to write the 1 there, but if it helps you, you definitely can. I'm going to cross these out. I'm going to go to my next one, which is 11b to the second. Since there aren't any other b to the seconds, it's just going to stay 11b to the second. And then same thing with that minus 6. It's just going to stay minus 6 as a constant. One last example is that a lot of times as you get into algebra, expressions are written to describe shapes. So here we have a triangle and we want to find the expression for the perimeter of the triangle. And remember, perimeter is just the distance around. In this situation, we just want to look at our like terms. So we have 2x, x, and 3x. Remember, we're adding all of these together. So we have 2x plus x is 3x plus 3x is more. We end up with 6x. And now the only other thing I have are a couple of constants. So I have 3 here and 2 here. So if I add 3 plus 2, I get 5. So the perimeter of our triangle would be 6x plus 5.